Okay, this is a lesson for Algebra 1, lesson 45, translating linear functions. The goal for today, objective students will describe the translation of linear functions. Okay, here's some vocabulary. The big word for today that we're learning is this thing called translation. We already learned about functions. Translation, okay? A translation, it says, is a type of transformation that moves every point in the same direction for the same distance. Translation is like sliding an object. So for example, let's say we had a graph. Actually, let me put some graph paper up there. Like so. Okay?
I can't see it.
No, you can't see it. I'll make it. Well, you can see it if you go on the recording. But let's just say that you had a graph that looked like this, okay? Okay? You all could imagine that, right? I could literally take this and slide it up, or I could slide it back down, or I could slide it lower. Okay, this is all called translations when I move it up or down. This is called a translation also. So it all depends what the problem says. So translating is sliding the graph up or down, okay? So another word for translation is to slide. What's another word for a translation?
To slide.
Okay, to slide. Okay, good. Okay, here are the steps. You should have those written down already. This is really important in your problem. You should talk about, this is a sentence frame. We're going to use that today. I'll show you how to use it. It's over there too. Okay. If you're on the video, you could pause it. If you didn't write it down, you could go back on the video. All right? Or copy it off the board. Number 1. Watch me do number 1. Graph f of x equals 2x and g of x equals 2x minus 6. When I look at these two equations, there's one equation and then there's a second equation here. This first equation has a slope of 2. The second equation also has a slope of 2. We learned last week that when they have the same slope, we know the lines are parallel, meaning they'll never touch. They are always in the same direction. They are parallel. Okay? So these both have the same slope. We know this one has a y-intercept of negative 6, and this other one doesn't have a y-intercept, so we're going to assume it's plus 0, because we don't have a y-intercept. We could just add 1, it's plus 0. Okay, so what we're going to do is graph it, and then we're going to describe the translation. Okay, so I'm going to draw my x and y axes. Bless you. Okay, first equation, f of x equals 2x plus 0. It's this one right here. So the first thing I'm going to do is plot my y-intercept, which is 0. Our slope is 2, which is 2 over 1. So we rise 2, run 1. I have a point here. Rise 2, run 1. I have a point here. And so forth. Okay, so we could take our line and draw it now. And we have our first equation here. Okay, watch carefully. This is our first line. Everyone memorize where the first line is. Now we're going to draw the second line. Our y-intercept is negative 6. 1, 2, 3, 4, 5, 6. Draw your point. Rises 2, run 1. Rises 2, runs 1. Okay? So, graph your line, and you notice that it's parallel, right? These two lines will not touch. Now, when I look at this, this was my first line. The second line, I just slid up or down?
Yeah.
Down, right? The second line, I slid down to make the second line, okay? So this was my first line, this was my second line. I'm going to describe the transformation now using my sentence frame. Okay, so my sentence frame says the graph of and we're going to use the second line, so this graph, which is g of x equals 2x minus 6, g of x equals 2x minus 6, and we continue, is the result of the transformation it's the result of the transformation of the graph I went too far this way. Of the graph f of x equals 2x. And we know it went down how many units? I count from this y-intercept down to this one. So I went down 1, 2, 3, 4, 5, 6. So I went down 6 units. 6 units down. And that's it. Okay? What this is saying is that this graph was made because I took this graph and I slid it 6 units down. I slid it 6 units down. Does that make sense? So we transformed it, okay? Or translated it, okay? It's supposed to say translation. I don't know why I wrote transformation. Let's try that again. My bad. Sorry about that.
Translation or transformation?
It's supposed to say translation. But of course you're not writing because it's pencils down, right? Translation. Okay? Watch me do number 2 now. Ready? Here we go. Number 2, graphing my x-axis, graphing my y-axis, and my first equation is f of x is equal to x plus 4, so I go to plus 4, plot my y-intercept, and it's up, rise 1, run 1, put a point here, and so forth. And we have our first line right here. Okay? Second line is x minus 2, go to negative 2, run one, up 1, run 1. And again, we have the same slope, so these should be 2 parallel lines. 2 parallel lines, so if I were to graph this, it should look like that. Okay? This was my first line, this is my second line. How did I make my second line? I took my first line and I translated it up or down. Translated it down, right? So, I start by writing the graph of, let's see, this one is g of x equals x minus 2 is the results of the translation of f of x, which is equal to x plus 4, and I count y-intercept to y-intercept. I went down 1, 2, 3, 4, 5, 6 again, okay? 6 units down, and I went down, right? And that's it. Any questions on these 2 examples?
It's really easy.
Super easy, right? All we're doing is sliding, okay? So there's a lot more writing on this these problems. Well, yeah, there's just writing, but the actual what we're doing is very easy. We just have to describe what's happening, okay? Yes.
What if there's like no x? Do you just do 1/1?
If there's no x,
Yeah.
if there's no x, how many x's are there?
None.
What number is none?
0.
So there's 0 x's. What's our slope for 0x?
That's 1/1.
What's the number in front of x?
Negative
1.
0x. What's the number in front of x?
0.
There you go. What's your slope?
0.
0. There you go.
So you don't have a slope.
Yeah, there's no slope. It's flat.
Oh.
Right?
Okay.
Okay, so let's have the 1s tell the 2s about how we graph the first 2 examples. 2s tell 1s about how we write it, okay? Ready, set, go.